We started out in the GNC area, but we've got a lot of folks doing a lot of different things. We moved into flight software many years ago, integration test, independent validation verification, sim development, even trajectory mission design analysis. We've got a lot of programs that we work with, including Orion, Commercial Crew, Commercial Resupply Services 1 and 2. I've done a lot of work over many years with visiting vehicle integration, supporting an exploration mission in several different places, including analysis, design, and flight software. We're doing a lot of work with flight dynamics for mission operations. We have people supporting ISS ops right now. And we've done quite a few different satellites, LEO and beyond. Some of our areas for NASA, we're supporting some of the things you've heard today, Project Gateway, moon missions, several others. We've been working CFS platforms of different types for different customers and NASA. Support on Orion backup flight system, voting architectures, distributed CFS integration, new apps and libraries all the time for all the different customers and needs. Doing some IR&D for human-in-the-loop mock-ups, integrated flight software simulations, one of our core strengths. And then a lot more work in recent years on commercial applications, which I can't tell you the customers, but all of them involve integrated flight software simulations, test satellites, science satellites, quite a few others, and surprisingly, the other things pop up where you can use CFS, including on the ground. Okay. Thank you. Okay, so as far as CFS, we've moved into a full stack. At first, we started out in apps and doing some work in the OSAL, and we've got folks on several projects now that have worked all the way from BSP at the operating system level, bootloaders, custom drivers, all the way up to custom CFS apps, libraries. And it's not just command and data handling, it's GNC and quite a few other things. It also reaches into dev test, ground support. And we found, as we've done a lot of this, that training and consulting actually becomes very important for new users of CFS. We also eat our own dog food. We train our own people. And we're coming up with more training classes, materials, how-tos, and stuff as we go. And so that's lessons learned that we're doing. We've got a lot of opportunities going on right now for development, government and commercial, both CFS and non-CFS. So Thad Fleming is here to talk about some of the things he's seen lately on some of his projects for Linux lessons learned.
Hi all, can you hear me all right? So those of you who are subscribed to the CFS mailing list will have already seen a little bit of this, but the main thing I want to talk about with CFS on Linux is how to get the real-time thread priorities without root. So usually the way that when people are running CFS on Linux for development purposes, if you can't run as root, you can't set the threads to have real-time schedulers, so you can set their priorities and so on. And so it makes the timing very difficult to study. But as it turns out, it's actually not necessary to be root on Linux in order to set a thread to use a real-time scheduler and set its priority. They have a couple of different ways that you can do that. One is their capability system, and the other is resource limits. And the principle of least privilege says if you can get away without being root, you should. So I'm going to, like I said, there's a couple of different methods to do this. There's capabilities, and then there's this resource limit. This capsys nice capability, the pro of it is there's less change to CFS code that you have to do, but it's not as easy to use in development, which is really what we want anyway, because that's applied on a per file basis, and so every time you rebuild, you'd have to reapply that, and it's kind of a pain. So for development use, I'm recommending the resource limit, this Linux-specific rlimit RT prio. That's something that your IT folks can set in your PAM limits config. You can set it on a per group basis or per user basis. And then it requires a small patch to the Linux PSP. It's 2 to 4 lines, depending on whether you check for an error code or not. And that just requests that your process run with this elevated limit. So at Odyssey, we've been running with this rlimit this R limit increased lately, and so our developers have been able to, if they have the right PSP version, run with these real-time priorities. Now there is a hitch. The POSIX OSAL assumes that if you're not root, you can't set these things. And so they check your effective user ID, and if that's not 0, if you're not root, it doesn't even try. And this isn't a POSIX thing. POSIX doesn't say what permissions or if any permissions are needed to set a real-time priority. So it's actually more portable just to go ahead and try it and see if you get an error. So a few patches in the POSIX OSAL, just removing those get EUID calls, would be needed. The POSIX NG OSAL, as mentioned earlier this morning, that already does the right thing. It just tries to do it. A couple of other things here. Something we've discovered recently, or I've figured out recently, is that on Linux, like many operating systems, you have a separate run queue for each CPU. And so your priorities are only enforced on a per CPU basis. So if you're running on multiple cores, you can't assume that you have strict task ordering between the CPUs. So in order to get the behavior that you're expecting, you probably want to limit CFS to a single CPU. And fortunately, that's something that you can do reasonably easily with Linux. You can actually tell Linux to get everything else off of that CPU. If you have hardware support, you can even have all of your interrupts handled on the other CPUs with a couple of kernel command line parameters. And then once you boot, you can just use task set to shift your CFS instance over onto that CPU that's reserved for it, run it with real time, and you'll get as good a performance as you can on mainline Linux. A couple of other smaller patches that I've put together and we will distribute somehow. One is just, you can set the names of your threads. So if you're in GDB and you do info thread, you can see different tasks names rather than just core linux.bin 14 times. And this is a very easy thing because OSAL already takes a name for the threads. So if you just plug in a Linux-specific system call in the right place, then it makes the debugging experience a lot easier. Another thing I mentioned or talked about on the CFS mailing list as well was that the ESPerf log is not multi-threaded safe. It's one of the last remaining things, even in 6.6, that wasn't apparently. And so if you get perf logs where it looks like sometimes things are sometimes things are not stopping or not starting, this may be your issue. You may have a race condition in there. So it's easy enough just to wrap that in a no-cell semaphore. It's not an ideal fix, but at least you don't get corrupted data. Other than that, you can get Linux provides sub-microsecond resolution on its timestamps. You can get that in your perf logs if you modify part of the PSP, which is in the current version, it calls an OSAL function and truncates down to microsecond level precision. But if you just skip that and use the call directly, you can get your nanosecond level precision in your perf logs. And then I believe this next one is due to Joe Hickey, but I wanted to mention it. You can not leak your message queues. People who've run CFS on Linux have probably seen this. Eventually, if you restart too many times, you can't get any pipes because you've run out of message queues. And the trick is that you don't actually need a message queue file instance since it's all in the same process. So you can just delete it immediately after you open it and you won't leak. There's a couple of APIs that Linux provides that could be looked into for future use. The proc file system gives all sorts of system statistics. The health and status app doesn't work well on Linux in terms of determining CPU usage, and so this is a case where using that Linux API might have some promise. And there's another extension that lets you inspect the dynamic libraries you have loaded. So there's a couple of bits of the OSAL, a simple table dump, and a module information call that could be implemented in terms of this. And this extension is actually on several BSDs as well as just Linux. Anyway, that's a few bits for Linux.
Okay. Are we on? Good. So in addition to several projects with Linux, we got some projects using RTEMS, and we've got a few lessons learned here. I'm not going to say everything because you all can read, and you need to stay awake after lunch because Lord knows I would be falling asleep right now too after lunch. But this project is using a UT700 Leon 3 fault-tolerant 32-bit processor, and we're using a CP650, waiting for 6.6, but it won't be for this project, but I'm looking forward to 6.6 when it comes out. The objective on this particular project was to really minimize any changes to the CFE and as few changes to the existing CFS apps as we could. We really wanted to concentrate on code reuse for all the stuff that was already out there and put all our effort into all the custom stuff that was needed. This one was going for RTEMS 5.1. Not sure if we're going to actually get on the official one, but we've been running on the pre-release for the main for 5 for a while now. And so for this, we had to do pretty much the whole stack, custom BSP, PSP, and then quite a few custom specific apps in addition to the customer who needed it. The development environment, we had several. Linux on x86-64, whereas your standard PC, Linux, PSP, and OSAL, that worked very well for getting a lot of things going first and doing quick development because you already have all the tools, low barrier to entry. We ran some smoke tests with the full stack in Qemu and Leon, but of course you got limited I/O and limited storage on that, so it's not the real thing. But it can actually, it's worth doing because even if you don't even have any I/O at all, just having it start up and see that it starts up will help you find problems, especially moving from one processor to the next. I'll talk a little bit more about that. And then we had the full stack running on actual dedicated hardware. For CP updates, we actually didn't have to do too much. There's one known bug that came out. I don't know if anyone has hit it. You may not actually use this command, but CP's got the shell output command. You send a command, and it'll pipe it directly to the shell, and the results will come back down in telemetry, throttled telemetry, so you don't overdrive things. And it's very useful, except that out of the box, unfortunately, it was limited to only 4 characters. I can do an ls, and I can do an ls space /, and that's it. Real easy fix. It's a one-liner, but you got to know it's there. You don't need it until you need it, and they need it bad. On the ccsds.h, the secondary header in the command was specified as a uint16, and on the Leon processor, everything is very alignment sensitive. And so the little things come and get you. And part of the lessons learned I'm bringing here today is that if you do your development on x86 and you move over to a processor that's just more picky, you're going to have surprises. And so that's when I want to come back with some war stories here. If you have a message that isn't perfectly aligned on, let's say, a 32-bit boundary, which the processor likes, and then you've got macros that go in and pull things out of that message, you're in for a rude surprise one day if you're off by 1 byte. Then your processor is going to halt. So we put in some tweaks there, and we had to go in and tweak a few different places through several different pieces of code, mostly our custom code. A lot of the stuff out of the box worked pretty well. But every now and then you'd find something and realize, ooh, that could be dangerous because I don't want my processor to halt while I'm flying. Let's see, some of the updates we had to do, some of the apps. CFDP we're relying on to get things from the ground to the vehicle and back and forth. We're using the 221, which is the same open source copy any of you all could download today. Our goal with all of these that I'm presenting here is to release them open source. Our customer is still working through the open source release process, so it's not an if, it's a when. And I already told Brian, who's my boss here today, Brian, I'm going to stand up here and talk this stuff, and it's not out. We understand it's not a if, it's a when. And so here I am telling you what we encountered so that you can be aware of it, and then hopefully we'll have the code out here for too terribly long. So for CF, we actually had to go in and change some of the message limits that I had, because built in, it was defaulted to the CP subscribe before. Well, if I send a file that takes up about 4 PDUs, By the time you have the initiation PDU, your 4 data PDUs, and then the termination PDU, you've already lost 2 messages. And so we couldn't figure out for a while why we were always losing message number 4. Well, it was a real simple fix, and we put that in there and made it configurable so we can actually open up the message limit for the PDUs coming into the app. We fixed the account that was in there where if you wanted to see what count your throttling semaphore was, it was actually making use of functionality that's only supported by one of the several OSALs. And so we fixed it so that all OSALs will properly support that count coming back down in telemetry. Very helpful if you have to get the CF app unwedged. We had to add wrappers because CF, due to its heritage in the library it wraps, it makes a lot of POSIX calls. And so we went in and rewrapped those and made them go to all the CFE calls. And the one that was for time, we chose to wire to the PSP time. But just be aware that if you're allergic to POSIX calls for one reason or another, it's actually making them. And so it's actually going around the OSAL out of the box. It may not be a problem for you. For us, we decided we didn't want to do that. But again, war stories to let you know. We did have some Indian assumptions and data alignment fixes. And again, we discovered that, well, not on the x86, but when we went back and forth between the x86 and the Leon. I think a couple of these are ones tracking in Babelfish, and all I've done, I have done a lot of NAS support in the past and had access to Babelfish. I don't have access to Babelfish for this project because it's commercial work. So I believe these are the issue numbers, and when we get you guys the changes, you guys can confirm it, but I've got to play by the rules. For HS, since we're using RTEMS, we're able to add in an RTEMS-specific custom layer so that you can actually get the per-thread CPU utilization and get the CPU loading. So that should support current RTEMS. We actually created and beefed up an RTEMS API so you can get that programmatically. And I thought that was pretty useful, and maybe the RTEMS guys might want to get that and include it. But we've got that along with our HS custom. MM and MD. MD was great, worked out of the box, except if you moved it to something that's not a Linux linker was totally happy, and then the Leon 3 linker said, no, you've got your app data defined in the header, not the source. It said, that's twice, I don't like it. It's a real simple bug fix. It looks like something was transposed during development. You wouldn't have found it unless you moved on to a different platform with a different tool chain. A memory manager, this is critical because we have to load and patch files in space, and MM is the way you're going to do it. We have some memory that you can only access on 32-bit strides, so we said, hey, it's already got that functionality in there. Except when we dumped memory, there was a bug in the stride, and so it would walk off into the wrong region of memory. And so we were able to fix that and note some of the assumptions that are there in the configuration arguments. So I don't know if anyone ever needs to use this data-aligned memory access, but if you need it, you're going to run into the same trouble that we had, and so we got it fixed for the 16 and the 32. You probably heard last year I was talking about the RTEMS OSAL. That has moved off from the 4.11 that we were doing a while, and we're now on 5. It's been working really well. In fact, we've closed out development. We made it sort of less idiot-proof, if that's the right word, so that if you were to load something and then unload something, or load something and it still had missing symbols, you wouldn't be in that big of trouble. The OSAL will check to make sure everything is copacetic before it proceeds after the loader, and that's actually worked out very well. For the performance monitoring and the CFE time support, built into the architecture of CFE 650A and the OSAL, it uses interrupt locks and task preemption settings to basically enforce thread access. Yes, it doesn't go for multiprocessors. We don't have one. We only have a single processor. And so we just bit the bullet and went ahead and implemented it and tested it on our hardware to make sure that that's safe and has the desired effect. Along the way, we found there's a couple of tools that we really needed and weren't provided, so we wrote them, and we'd like to get them out to the community because I think they're general purpose and useful. But if you're using MM, and you need to create an MM load file from one of your binary blobs from your compiler, what have you, then we can do that now. It's a real simple command line tool, and you just give the binary blob some parameters, and it'll create an MM file for loading. And it's useful for patching or loading up other information in memory. Another one we found is that if you're comparing CRC matches from your FM results to see if did a file make it on board right, or was it corrupted, get a CRC for that file. Or if I want to do a one-shot checksum for a portion of memory, well, you don't know how to get the CRC on the ground to compare what your flight software is telling you. So again, a real simple tool to just fill in the cracks, and it goes a long way. Thad talked about some of the PSP efforts. One of the other things that we needed was we were deploying CFS on the ground. We actually did need the PSP to be an exact lockstep with the system clock, which is not a standard use case for CFS, but it's actually pretty straightforward to go ahead and use a kernel facility to sync the clock and use the CFE time sync mechanism that's built in. So we've got a PSP that syncs, and I think that's pretty useful. So the lessons learned, I alluded to it, but really, sometimes it depends on what processor you attack first, whether you really have portable code or whether you don't have portable code. It's pretty easy to develop non-portable code if you go from a very lenient processor to a very restricted processor. I'm not saying Leon is very restrictive, but I'm saying it is more restrictive than x86. And so when I've had conversations with app developers versus, let's say, BSP guys or folks who deal with the hardware, the guys who are used to dealing with these types of issues for their bread and butter all the time, they don't see this as a problem. This is their daily work. This is what they do. But when you deal with a bunch of application developers who come from the x86 world, or they're out of school, or, it doesn't really matter. It really depends on your domain knowledge. The nice part about CFS is that you do not have to be an expert in all the crazy things that go on a flight system in order to develop an app that can actually function. But you can get yourself into rough territory, and it's things like alignment issues that, well, that's just fundamental to the platform. It will bubble up through all your architecture layers and get you by surprise, and you have to know that. And so some of the things that we did were to make things explicit, turn on all the compiler warnings that we could do, use fixed types, and you can go overboard with this. We may have gone overboard with it in a few areas, but once you've been burned a few times, you at least need to do something. So I won't say we've got the exact right balance, but getting stuff out for the developers earlier versus later, or preferably starting with it, is going to help. But that doesn't mean if you pull somebody else's quote-unquote reusable piece of code into your code base, you're not going to have problems with that code too. So you really do have to check out all the code that you bring in when you're hitting issues like this. For us, the OSAL, the PSP, and the BSP were under our control. But then you run into things that you don't necessarily want to control. If you've got code like the CFE or other apps that you just want to reuse, you don't want to go touch them. But sometimes you have to. Another thing that we kind of came across, and I think was discussed a little bit on the mailing list, other people have talked about it, I'll just shine a light on it. If you're running 32-bit CFE and you have 64-bit type, you're in trouble already, you just don't know it. Because CFE will put things on 32-bit boundaries, and you go to access something on a 64-bit type, it might be on a 64-bit boundary, or flip a coin, it might be on a 32. Some processors will say, okay, no problem, and then some processors won't, and you'll have a bad day. So again, if you're using certain type sizes for certain platforms, you can get into trouble. If you know your platform, you can already work around this, and I think just about all the apps in CFE and everything, they don't have 64-bit types built in anyway. But if you're trying to reuse apps from one architecture to another, you'll get surprised. So watch out for that. Other people have talked about this in many other presentations in the past couple of years, but again, just shining a light on it. Get your development environment under control immediately. And one of the first things you should do is make sure that you can build bit identical binaries and regularly check that. We had the VMs under configuration control from the early stage. And I got to say, on this project compared to other projects I've supported in the past, the number of tooling problems we have been very low. And so that was a big help. It's not free. You have to put a lot of work in to do it, but once you do it, you get the benefits. Keep the same compiler version, and what we had to do is when we went from RTEMS 4.11 to RTEMS 5, I went ahead and updated the host compiler they were using to be the same, and just having the consistent compiler warnings was a nice benefit. Turn all the warnings you can on early. Watch your task names. RTEMS convention was 4 characters. CFS is more than that. You don't want CFE underscore for everything. We fixed that in our OSAL. But on your task names, just be aware some platforms do have different limitations that will affect your debugging and things like that. Coordinate your priorities. Again, embedded people know this, but if you're coming from the application development realm, or you're a GNC person, or if you're somebody else who doesn't deal with application priorities and scheduling, it's going to be an issue, and you will end up with priority inversion. And so you need an expert to come in and do it upright. Surprising optimization, it can do great things, and then it can do great surprising things, which you don't have time to figure out. You will occasionally hit some surprises. In our case, we had an in-memory tar file system, and we had to end up telling it, no, you need to pull in the whole thing, and no, you really, really need to pull in the whole thing. Please, I need the whole thing. And you have to hit it with a hammer and get around the O2. But once you've done that, it's great. So RTEMS, with the real-time loader that they have, is embedded symbol table. We've been using the two-step link process. There's a couple of options in RTEMS on how to do that, but that's worked out great. You will need to do some linker help if you're bringing in like in the math library, or if you call some functions that maybe the kernel doesn't, they get optimized out. But again, it's pretty straightforward linker stuff. Don't leave Earth without your map file. There's just some things that aren't going to be public symbols, and you'll need to go get the memory addresses, especially if you're using MM and MD. And the console writes, depending on your system, you'll have printfs here or there. Printfs, if you're on a hard real-time system, they are the demon. Outlaw those suckers. What we did is we did have a lot, and we moved things to the OS printf, and then we moved that into an internal logging solution. You can wean off only so much, but then some things are just built with different printfs in there. And at some point, you just may have to just get in there and short-circuit it, and that helped a lot. But from an operations and a development point of view, not having the console, if that's what you're used to looking at, that's a big psychological step and is a big hit in terms of productivity and efficiency. So start thinking about tackling that one early. Having a software-in-the-loop environment with commands and telemetry early is critical. CFS on Linux was great for early development, but you still need to do the full stack testing. And probably you guys have already heard all these things, but it's pretty important. You want to have an engineering user interface early. I've done some projects where I didn't have much of an engineering user interface early, and I've done some projects where I did. That makes a big difference. If you want to start up CFE, CFS system with bringing a bunch of apps and get going, even before you write your first custom app, how do you know if it's running right? How do you know if you have things tuned right? You need a command and telemetry system to tell you that. So I highly suggest that even before you write your first app that is your custom app, stand up the system and look at the telemetry. Go through all the telemetry. Go through all the tuning. I mean, just have a look at it, see what's going on. At least be aware how your system's working. Scripting capabilities for test automation and checkout are critical, and if you get them in early, you can continue to use them through the life of the program. And if you're using CFDP, you may think your CF app is working great, but until you bounce it off of a peer that's also running, you're going to be surprised. And it's not the fault of an app. It's that you're testing a complicated protocol, and you need to do that early. And once you get things running on a flight-like platform, you're probably not going to have a back end to get stuff on and off the file system. You're going to use CFDP like you would use as an operator. So again, have a CFDP peer out there early. So that's it. That's our slides, and thanks for listening to our war stories. Appreciate it.
Just one quick question. The file CRC tool, does it support other kinds of checksumming systems or only the CRC?
It's built in for the CFE 16, which comes out of the box with CFE, and that's what we're flying. Again, like CFE, you can extend the file tool because we use the same code that CFE is using. So if you have a different one that you implement for CFE and CFS in this case, you can do the same code for the file tool and make sure they're matched.
Okay, thanks.
So we had an online question way back, and I didn't know if this was answered throughout your presentation. Has any experimentation been done with a RT Linux patch?
Ben?
We haven't done that yet. We haven't done that yet. That's actually something that we'll probably do within the next couple of months on one of my projects. So, yeah.
Okay, good. Thank you.
We have an ongoing effort with Xenimi Linux, which has got the RT patch, but it's much more deterministic and partitionable. So if anybody's interested in that, that's some work that TAM is actually funding, and it will be going in with CFE, if that's what you're looking for.
Well, I was just going to say it's also on one of your slides. There was a version that was written by Odyssey, the Xenimi 2.6.4, yeah.
Yeah, thanks, Matt.
Okay. Other questions?
Okay, thank you all very
Okay,
much.
thank you.